For tens of thousands of years, Antarctica has been imagined as a frozen wasteland, an inhospitable continent of ice, wind, and shadow, untouched by human presence and largely impervious to life. Yet beneath its thick, unbroken ice sheets lies a world frozen in time, a landscape that may conceal the remnants of an ancient civilization preserved for over 12,000 years. Beneath kilometers of snow and glacial compression, hidden valleys, mountains, subglacial lakes, and linear anomalies form patterns that defy simple geological explanation, suggesting urban planning, infrastructure, and architecture that align with habitable terrain, water systems, and natural corridors. Ice cores capture chemical, biological, and sedimentary records that hint at ecosystems far richer than previously imagined. Evidence of rivers, vegetation, and climate conditions that could have supported complex human activity. Across this frozen continent, terraces, linear depressions, rectilinear structures, and subglacial waterways hint at a civilization carefully adapted to its environment, integrating construction with natural features, hydrology, and topography. The continent's ice, simultaneously a barrier and a conservatory, preserves these features with an almost unbelievable fidelity, allowing us glimpses of streets, buildings, and urban networks suspended in stasis, waiting for technology and inquiry to uncover the hidden story of humanity's forgotten presence at the bottom of the world. Antarctica occupies the southernmost reaches of Earth, with a presence so immense that it resists ordinary human comprehension, not only because of its size, but because of the way it exists beyond familiarity. Covering more than 14 million square kilometers, larger than Europe and Australia combined, the continent dominates the planet's southern hemisphere, while remaining strangely absent from human imagination. From orbit, Antarctica appears as a continuous, luminous expanse of white, a surface so uniform that it erases scale, depth, and detail, presenting itself as a blank space at the edge of the world. This visual simplicity has shaped centuries of assumption, reinforcing the belief that Antarctica is a place without history, without variation, and without relevance to the broader story of life on Earth. The whiteness conceals not only the land beneath it, but the idea that anything meaningful could have existed there before the ice. This perception dissolves when Antarctica is viewed through the lens of geological time rather than human memory. The ice sheet that defines the continent today, though immense in volume and thickness, represents only a fleeting phase in Antarctica's long existence. Beneath the ice lies a continental foundation that formed hundreds of millions of years ago, shaped by tectonic collisions, continental drift, volcanic episodes, and repeated cycles of erosion and sedimentation. For vast stretches of its history, Antarctica was not frozen at all. It existed as part of ancient supercontinents, positioned farther north, bathed in milder climates, and shaped by rain, rivers, and coastal processes. The ice that now entombs the land is not its natural state, but a temporary condition imposed by a recent climatic shift in planetary terms. Modern technology has begun to strip away this illusion of permanence. Ice-penetrating radar, seismic imaging, and gravitational mapping have revealed a hidden Antarctica beneath the ice, a continent whose complexity rivals any other on Earth. Mountain ranges rise sharply from the bedrock, some stretching for thousands of kilometers, their peaks flattened and sculpted not solely by glacial pressure, but by prolonged exposure to wind, water, and atmosphere long before the ice arrived. Vast valleys cut across the continent in branching networks, their sinuous paths resembling river systems rather than glacial scars. These valleys descend toward ancient coastlines, now buried beneath ice shelves, forming drainage patterns that speak to sustained hydrological activity over immense spans of time. These features are not ambiguous. On every other continent, landscapes shaped in this way are unmistakably the product of flowing water, acting over long periods under open skies. Rivers carve, meander, and branch according to predictable physical laws, and the patterns visible beneath Antarctica conform to those laws with remarkable precision. Such river systems do more than shape terrain. They create fertile soils, regulate ecosystems, and provide stable access to resources, forming the environmental foundations upon which long-term settlement and civilization emerge. The subglacial geography of Antarctica mirrors these foundational landscapes, suggesting that the continent once supported ecological stability rather than perpetual extremity. Antarctica's present isolation reinforces the illusion that it has always been unreachable. Today, it is encircled by the Southern Ocean and shielded by powerful circumpolar currents that block warm water and stabilize extreme cold, effectively sealing it off from the rest of the world. Yet these barriers are neither eternal nor fixed. Ocean currents shift over geological time, sea levels rise and fall by hundreds of meters, and coastlines migrate across continents. In earlier epochs, Antarctica's separation from the rest of the world would have been far less absolute, allowing migration, interaction, and exploration across regions now divided by vast distances of ocean and ice. The belief that Antarctica exists outside human history arises not from evidence, but from projection. The present climate is imposed backward onto the past, transforming a temporary state into an imagined constant. Human memory spans only a fraction of Earth's climatic cycles, yet that narrow window is often treated as definitive. In doing so, entire chapters of planetary history vanish from consideration. Antarctica becomes a blank space, not because nothing happened there, but because modern conditions make it difficult to imagine that anything ever could have. Scientific attention on Antarctica has focused overwhelmingly on ice dynamics, atmospheric circulation, and climate forecasting. These studies are vital for understanding Earth's future, yet they leave little room for exploring the continent's deep human past. Archaeology, as traditionally practiced, is nearly impossible beneath kilometers of ice. The absence of excavation is often mistaken for the absence of evidence, even though the environment itself prevents discovery rather than disproving it. This creates a profound paradox. Antarctica is one of the most closely monitored regions on Earth, observed continuously by satellites, aircraft, and automated sensors, yet it remains one of the least physically explored. The surface is hostile, the interior inaccessible, and the land beneath the ice almost entirely untouched. What lies there is reconstructed indirectly, inferred from echoes and models rather than uncovered by human hands. In this sense, Antarctica functions less like an empty wilderness and more like a sealed archive on a planetary scale. Its ice does not erase the past, it preserves it. Shielded from erosion, biological decay, and human disturbance, the continent holds its history in suspension. The silence of Antarctica does not indicate absence. It reflects concealment, enforced by cold, pressure, and time. Long before Antarctica became synonymous with ice and desolation, it existed within a planetary system governed by very different rules. Geological and biological evidence recovered from beneath the ice reveals a continent once shaped by warmth, rainfall, and seasonal change rather than permanent cold. Fossilized pollen extracted from deep sediment cores includes species from flowering plants, ferns, and temperate trees that require stable growing seasons and moderate temperatures to survive. These findings are not isolated curiosities discovered in a single anomalous location. They appear repeatedly across drilling sites separated by vast distances, indicating that much of Antarctica once supported widespread vegetation rather than isolated pockets of warmth. The presence of these biological remnants confirms that the continent was once part of a living, breathing biosphere, capable of sustaining complex ecosystems over long periods of time. Sediment cores provide an even more detailed record of this lost environment. Layer upon layer of fine-grained deposits reveal the signatures of flowing water acting consistently over thousands of years. These layers document seasonal flooding, river migration, and gradual erosion, patterns that require open landscapes exposed to rainfall and meltwater rather than a frozen surface locked beneath ice. The structure of these sediments reflects the rhythms of an active hydrological cycle, one in which rivers carved valleys, transported nutrients, and reshaped the land year after year. Such processes do not occur in brief warm intervals or transitional climates. They demand long-term environmental stability, indicating that Antarctica remained ice-free for extended spans of time rather than fleeting geological moments. During this period, Antarctica was not an anomaly existing outside the planet's habitable zones. Global temperatures were significantly higher, polar ice was limited, and atmospheric circulation distributed heat more evenly across latitudes. The Earth functioned as a connected system in which regions now considered extreme were integrated into broader climatic balance. Antarctica's position in the southern hemisphere did not automatically condemn it to permanent cold. Instead, it supported environments comparable to those found in modern temperate regions, with coastlines shaped by tides, interior basins fed by rivers, and seasonal cycles that govern plant and animal life. The world's coastlines during this era looked dramatically different from those of today. Sea levels were lower, exposing vast continental shelves and creating land bridges that connected regions now separated by oceans. Migration across these expanded landscapes was not only possible, but inevitable. Human ancestors and early human populations followed resources rather than latitude, spreading across coastlines, river valleys, and plains wherever conditions allowed. Within this broader context, Antarctica would not have existed as an isolated outpost, but as a southern extension of the inhabitable world, accessible during periods when climate and sea level aligned. Human adaptability during this deep past is increasingly difficult to underestimate. Archaeological discoveries across multiple continents reveal organized behavior, symbolic expression, and complex social structures tens of thousands of years earlier than traditional timelines once allowed. These findings challenge the notion that early humans were limited to simple survival strategies or confined to narrow ecological niches. Instead, they demonstrate an ability to exploit diverse environments, from deserts to rainforests, from coastlines to high plateaus. Within this expanded understanding of early human capability, Antarctica's exclusion from habitation becomes a matter of assumption rather than certainty. The Younger Dryas event marked a sudden and catastrophic disruption to this planetary balance. Ice core records from Greenland and Antarctica document an abrupt temperature decline occurring over mere decades, a geological instant with profound consequences. This rapid cooling altered ocean circulation, weakened heat transport from the equator, and triggered widespread glaciation across both hemispheres. Ecosystems collapsed faster than species could adapt, forcing human populations worldwide into migration, innovation, or extinction. The stability that had allowed long-term settlement in many regions vanished almost overnight. For Antarctica, the effects of this shift would have been absolute. Snow accumulation increased dramatically as temperatures fell, overwhelming seasonal melt cycles that had once regulated the landscape. Year after year, snow compacted into ice, thickening and spreading outward from high elevations and interior basins. Rivers that had flowed for millennia froze solid. Lakes vanished beneath accumulating ice. Coastlines retreated as ice sheets advanced toward the sea, sealing off access to marine resources and erasing the boundary between land and ocean. Any population living on the continent during this transition would have faced conditions that deteriorated with terrifying speed. Agricultural systems would fail almost immediately as growing seasons collapsed. Wildlife would migrate northward or perish, removing critical food sources. Infrastructure designed for temperate conditions would become useless as ice advanced relentlessly across the landscape. Survival would depend on rapid evacuation rather than adaptation, forcing abandonment on a scale rarely experienced in human history. This abandonment would not resemble the gradual decline seen in many ancient societies. It would be abrupt, driven by necessity rather than choice. Settlements would be left standing. Roads, dwellings, and communal spaces would remain where they were built, overtaken by encroaching ice rather than dismantled or destroyed. Human presence would end suddenly, leaving behind a material record frozen in place. Unlike erosion, fire, or tectonic upheaval, glaciation preserves structure. Ice compresses rather than scatters, sealing landscapes beneath successive layers that protect them from wind, rain, and biological decay. What existed on Antarctica's surface at the moment of abandonment would remain there, locked beneath kilometers of ice, unchanged except by pressure and time. The freeze did not erase the continent's past. It isolated it from access. The transition into Antarctica's frozen state represents not a slow fading from memory, but a severing of continuity. Knowledge of what existed there would disappear within generations, not because it was forgotten, but because the land itself became unreachable. Whatever stories survived would do so only indirectly, carried away by those who escaped, fragmented by distance and reshaped by time, equals. Long before Antarctica entered the modern world as a continent of ice and isolation, it existed in human knowledge in ways that defy conventional explanation. Evidence of this survival does not appear in ruins or inscriptions carved into stone, but in something more fragile and unlikely to endure across millennia: maps. Ancient and early modern cartographic works contain depictions of a southern landmass that bear an unsettling resemblance to Antarctica, not as it exists today, but as it would appear without ice. These maps emerged centuries before the technology required to explore the southern polar regions, and long before Antarctica was officially sighted by modern expeditions, suggesting access to information inherited rather than discovered. The most famous of these documents is the Piri Reis map, compiled in 1513 by an Ottoman admiral and navigator. The map portrays portions of Europe, Africa, and a southern landmass with coastlines rendered in striking detail. What sets it apart is the accuracy of that southern coastline, which aligns closely with modern reconstructions of Antarctica's bedrock contours beneath the ice, rather than the ice-covered coastline visible today. Bays, capes, and shoreline curves correspond with features revealed only in the 20th century through seismic imaging and ice-penetrating radar. The distinction is critical. The map does not depict glaciers, ice shelves, or distorted polar shapes. It shows land as it would appear in a temperate state. Piri Reis himself offered an explanation that only deepens the mystery. In marginal notes, he stated that his map was compiled from much older source charts, some inherited from ancient libraries and maritime traditions. These sources, he claimed, dated back thousands of years and were already fragmentary by the time they reached him. Though these original maps are now lost, their influence survives through the precision of the final product. The accuracy suggests systematic observation accumulated over long periods rather than conjecture or artistic invention. The Piri Reis map is not an isolated anomaly. Other cartographers across Europe produced similar representations of a southern continent during the 16th and 17th centuries. Oronce Fine's 1,531 world map depicts a massive landmass labeled Terra Australis, complete with rivers flowing inland and mountain ranges rising from its interior. These features were not decorative flourishes. Many correspond closely with subglacial formations mapped beneath Antarctica's ice centuries later, including drainage basins and interior elevations that would have been impossible to infer without direct knowledge of the land. In 1737, French cartographer Philippe Wache introduced another startling detail. His map depicted Antarctica as divided into two large landmasses separated by an inland sea. At the time, this idea was dismissed as speculative geography, a creative attempt to balance the continents of the Northern Hemisphere. Yet modern radar surveys have revealed extensive subglacial lakes and interconnected water systems beneath the Antarctic ice sheet, including massive bodies of liquid water sealed beneath kilometers of ice. While Wache could not have known their precise nature, the structural concept aligns uncannily with what science later confirmed. The consistency of these maps across different cultures and time periods suggests continuity rather than coincidence. They reflect a shared inheritance of geographic knowledge passed down through generations who no longer understood its origin. Such inheritance implies observers who mapped the world before catastrophic climatic changes altered its surface, preserving information from a time when Antarctica was accessible and ice-free. Cartography functions as a vessel of memory, capable of outlasting the civilizations that produce it. When societies collapse, their knowledge does not vanish instantly. It fragments, migrates, and embeds itself within later traditions, copied and recopied, even as its meaning fades. In this way, maps can preserve truths long after the context that made them intelligible has disappeared. The survival of Antarctic geography implies capabilities that challenge traditional timelines. Accurate mapping requires navigation, measurement, and an understanding of latitude and longitude. These skills suggest a level of technological and observational sophistication rarely attributed to prehistoric cultures. Yet the maps themselves exist, carrying information that could not have originated in the eras traditionally assigned to them. Rather than emerging spontaneously during the age of exploration, this knowledge appears inherited. Later civilizations rediscovered fragments of a much older world and preserved them without fully understanding their significance. What appeared as speculative geography may in fact represent the echo of a lost reality. These maps do not announce discovery. They record remembrance. Ice is often associated with destruction, with the erasure of life and the dominance of silence. Yet, in geological and archaeological terms, ice functions less as a destroyer and more as a preserver. Unlike wind, rain, biological activity, or tectonic movement, ice halts change rather than accelerating it. When landscapes are buried beneath thick, stable ice sheets, erosion slows to a near standstill. Oxygen is excluded, microbial activity is suppressed, and temperature fluctuations are minimized. In such conditions, the passage of time loses much of its power to degrade. Antarctica's ice sheet, reaching thicknesses of several kilometers in some regions, represents one of the most effective preservation systems on the planet, capable of locking entire environments into a state of suspended animation for tens of thousands of years. Examples of ice preservation elsewhere on Earth provide a glimpse of what such conditions can achieve. In Siberian permafrost, entire mammoths have been recovered with flesh, hair, and internal organs intact after more than 30,000 years. Ancient plant matter, seeds, and microorganisms have been revived after millennia frozen beneath ice. Human remains discovered in alpine glaciers retain clothing, tools, and even facial features, long after similar materials would have decayed completely in temperate environments. These discoveries demonstrate that ice does not erase history, it pauses it, sealing moments in time with a fidelity unmatched by any other natural process. Antarctica amplifies this effect on a continental scale. The ice sheet that blankets the land is not uniform chaos, but a layered archive, accumulating year after year as snow compresses into ice. Each layer records atmospheric conditions, volcanic events, and environmental shifts, forming a stratified timeline stretching back hundreds of thousands of years. Beneath these layers lies the ancient surface, isolated from external forces and protected from the destructive cycles that erase archaeological evidence elsewhere. If structures existed on that surface when the ice advanced, they would not have been scattered or reduced to rubble. They would have been entombed intact, preserved beneath immense pressure, but minimal chemical degradation. Stone structures, in particular, would fare remarkably well under such conditions. Stone does not rot, and when shielded from weathering agents like water flow, temperature fluctuation, and biological growth, it can remain unchanged for extraordinary lengths of time. Foundations, walls, roadways, and terraces could survive beneath Antarctic ice with their geometry intact, compressed downward but not displaced. Even complex architectural layouts could remain legible beneath the ice, their outlines preserved in the frozen bedrock surface below. Metal artifacts, often assumed to corrode rapidly, would also experience slowed degradation in the oxygen-poor, frozen environment beneath the ice. While corrosion would not halt entirely, it would progress at a fraction of the rate seen in open air or wet conditions. Organic materials, typically the first to decay, could survive in sealed pockets where temperature and oxygen levels remain stable. Wood, textiles, and even written materials could persist far longer than expected, protected by the same conditions that preserve ancient biological specimens in permafrost. The key distinction lies in how glaciation differs from other forms of environmental destruction. Floods scatter debris, earthquakes fracture and bury unevenly, volcanic eruptions incinerate and distort. Ice, by contrast, advances slowly but relentlessly, covering landscapes without tearing them apart. It preserves spatial relationships. Roads remain aligned. Structures remain where they were built. Settlements remain settlements, frozen in the moment they were abandoned. This preservation is not hypothetical. Radar surveys conducted across Antarctica have already revealed anomalies beneath the ice that do not conform neatly to known geological patterns. In some regions, researchers have detected rectilinear features, sharp angles, and isolated formations that contrast with the surrounding natural terrain. While such anomalies are often attributed to subglacial geology, the limitations of resolution and access leave their true nature unresolved. In a continent where direct excavation is nearly impossible, uncertainty persists by necessity rather than neglect. The scale of Antarctica compounds this uncertainty. Vast regions of the continent remain only partially mapped beneath the ice, with radar coverage that provides broad outlines but not fine detail. Entire mountain ranges and basins remain unexplored, even indirectly. If structures exist beneath the ice, they could remain undetected simply because no one has looked closely enough, or because existing instruments are not designed to search for archaeological pattern. Unlike deserts or jungles, Antarctica has not been subjected to millennia of human reuse. There are no later civilizations building atop earlier ruins, no continuous occupation that alters or repurposes ancient structures. If a civilization once existed there and was forced to abandon the land rapidly, its material remains would have been left untouched, sealed beneath ice without interference. In this sense, Antarctica offers something no other continent can: the possibility of an unaltered archaeological record, preserved exactly as it was at the moment of collapse. This preservation comes at a cost. The same ice that protects also conceals. Antarctica's past is not destroyed, but it is inaccessible, locked beneath kilometers of frozen mass that resists excavation and exploration. International treaties restrict large-scale disturbance, and the technological challenges of deep ice drilling make targeted investigation extraordinarily difficult. As a result, Antarctica remains both the best preserved and least explored potential archive of ancient human history on Earth. Ice transforms time into depth. The deeper one looks, the further back in history one goes. Beneath Antarctica's ice lies not merely a frozen wilderness, but a layered record of worlds that came before, waiting beneath pressure and cold, intact but unseen, preserved rather than erased by the passage of millennia. Beneath Antarctica's frozen surface lies a hidden world, a landscape sculpted over millions of years, yet entirely invisible to the human eye. The first glimpses of this subterranean continent came not from boots on ice, but from technology capable of piercing the kilometers-thick sheets that blanket the land. Ice-penetrating radar, seismic reflection surveys, and satellite-based gravitational measurements have revealed valleys, plateaus, mountains, and lakes entirely isolated from the surface. These tools, designed originally for climate and geological studies, have unintentionally created a map of potential archaeology, showing a continent whose complexity rivals any in the known world, but whose secrets remain locked beneath an impermeable shield of ice. The signals collected from these instruments are more than mere scientific data. They are whispers of a landscape that has endured, untouched by wind, rain, or human interference, for tens of thousands of years. Among the most striking discoveries are the subglacial lakes scattered across the continent, hundreds in number, some of them larger than Lake Ontario. These bodies of liquid water persist in isolation beneath kilometers of ice, maintained by geothermal heat and pressure. They represent closed ecological systems that have existed for millennia, untouched by the surface world. Water beneath the ice is not inert. It is dynamic, flowing in underground channels, filling basins, and potentially interacting with the bedrock and sediments beneath. The presence of these lakes is itself a geological anomaly, a defiance of expectations, and it suggests that the continent's frozen surface conceals a world that is far from uniform, a mosaic of valleys, rivers, and basins that echoes the landscapes of Antarctica before the ice claimed it. For anyone searching for signs of past habitation, these lakes and channels represent areas where resources may have concentrated, creating the very conditions that once make life and civilization possible. Radar surveys have revealed even more perplexing patterns. Certain regions display geometric formations, rectilinear anomalies, and sharply defined edges that do not conform to natural erosion or glaciation. While many of these patterns are assumed to be geological in origin, the resolution of current instruments leaves room for speculation. Some formations suggest the possibility of structures, pathways, or terraces buried beneath ice for thousands of years, preserved in their original spatial relationships by the relentless compression of snow and ice. The regularity of angles, the linearity of certain channels, and the apparent symmetry of some features resist straightforward geological explanation, raising the tantalizing question: could these signals be the remnants of something intentionally constructed? A civilization frozen in place by climatic catastrophe? Beyond radar, satellite imaging has offered additional hints. Gravity measurements detect mass anomalies beneath the ice, areas where density varies in ways inconsistent with surrounding bedrock. Magnetic surveys reveal irregularities that might indicate artificial materials, though they could also represent unusual geological formations. The patterns are faint, diffuse, and easily dismissed, yet they persist across multiple independent surveys. When viewed collectively, these datasets create a portrait of a continent far more intricate than surface observation allows, suggesting that Antarctica's past is recorded not in obvious ruins, but in subtle distortions, in the faint echoes of structures hidden by ice, waiting to be interpreted. The distribution of these anomalies is striking. They are concentrated in areas that, prior to glaciation, would have been river valleys, coastal plains, and mountain basins, precisely the types of terrain known historically to support settlement and human activity. These zones combine accessibility with natural protection, fertile soils, and water resources, forming a landscape that, if it had existed in the recent past, would have been ideal for habitation. For archaeologists constrained by the inability to excavate ice-covered terrain, this convergence of favorable geography and anomalous signals suggests that the possibility of past civilization cannot be dismissed outright. The continent, though frozen, preserves hints of a story written in stone, sediment, and liquid water, waiting to be read. In addition to geomorphological signals, scientists have observed signs of unusual subglacial activity that further complicate the narrative. Certain lakes and channels exhibit flow rates, sediment deposition patterns, and thermal signatures inconsistent with purely natural processes. These anomalies may represent interactions between water and bedrock, geothermal activity, or long-term movement of ice. Yet they also raise the possibility that human or intelligent activity once influenced the distribution of materials across the landscape. In an environment where natural processes are typically slow and predictable, the presence of irregularities invites careful attention and perhaps a reconsideration of assumptions about what Antarctica's ice can conceal. The preservation of these features is remarkable. Unlike landscapes exposed to weathering and human activity, subglacial terrains have remained stable for tens of thousands of years. The pressure of overlying ice maintains topographical fidelity, ensuring that whatever exists beneath is preserved not only physically but spatially, in the positions it held at the moment the ice advanced. Roads, terraces, and artificial alignments, if they exist, would be compressed but essentially intact, their forms safeguarded against erosion and decay. In this way, Antarctica acts as a planetary vault, not erasing its past, but suspending it, a frozen repository of potentially unparalleled significance. These signals beneath the ice demand reinterpretation of long-held assumptions. Conventional science regards Antarctica as a continent devoid of human history until modern exploration. Yet the combination of geometric anomalies, subglacial lakes, and concentrated areas of unusual topography suggests an environment far more structured and hospitable in the distant past than previously thought. If patterns once dictated by human activity persist beneath the ice, the continent's history may be far richer than any record preserved above the frozen surface. Ice, technology, and geological processes together create both a barrier and a record. What lies beneath cannot be accessed by conventional excavation, yet it is detectable through the careful interpretation of radar echoes, satellite gravimetry, and magnetic surveys. Antarctica's hidden world is neither myth nor speculation. It is a landscape frozen, preserved, and recorded in data streams that modern science can just begin to decipher. The continent does not announce its secrets. It hints at them, leaving the most determined observer to piece together a story encoded in ice, water, and stone. The signals beneath the ice represent the faint voice of a lost continent, a record of landscapes and possibly civilizations preserved in layers invisible to the naked eye. Every anomaly, every deviation from natural expectation, is a clue, a piece of evidence pointing to a past that existed long before the ice claimed the land and long before human memory could record it. Antarctica, for all its current silence and apparent emptiness, is alive with data, and within that frozen archive may lie the keys to understanding civilizations lost not to time alone, but to the transformative power of ice itself. Beneath Antarctica's immense ice sheet, the possibility of past human activity exists not as a rumor, but as a series of tantalizing signals, encoded in patterns, anomalies, and preserved landscapes that defy simple explanation. Radar and satellite surveys have revealed regions where bedrock formations display unusual regularity. Straight lines, right angles, terraces, and isolated rectangular structures that contrast sharply with the surrounding natural terrain. While traditional geology can account for some irregularities, the frequency, distribution, and orientation of these anomalies suggest an underlying order inconsistent with natural erosion, glaciation, or tectonic processes. The shapes are subtle, often detectable only with high-resolution radar, yet their presence is persistent, recurring in areas that before glaciation would have been valleys, plateaus, or coastal plains. These are precisely the types of landscapes historically favored by civilizations. They offer water, access to fertile soil, and strategic advantages for settlement. In this sense, Antarctica's ice may have preserved echoes of human activity, entombing the remnants of structures and settlements in an inaccessible archive, compressed under kilometers of ice, but otherwise intact. The concept of preserved settlement beneath ice is not unprecedented, though Antarctica presents the most extreme case. In other regions, rapid environmental shifts have forced societies to abandon entire cities, leaving them remarkably intact. The ruins of ancient settlements buried under volcanic ash, the preserved temples beneath desert sands, and even glacially entombed alpine villages demonstrate that human-made structures can survive for millennia under protective layers. Ice offers one of the most effective forms of preservation imaginable: halting decay, microbial activity, and physical erosion. And Antarctica, with its vast unbroken sheets of frozen accumulation, could act as a global-scale equivalent. Foundations, roads, terraces, and complex structural layouts, if they existed at the time of glaciation, may still lie beneath the ice in positions and orientations left exactly as they were. A civilization suspended in geological stasis. Subglacial lakes, channels, and hidden valleys complicate the narrative and hint at a possible resource network that a civilization could have exploited. Hundreds of subglacial lakes, some larger than modern metropolitan areas, exist in isolation beneath kilometers of ice, connected by flowing channels and perhaps fed by geothermal heat. These bodies of water would have provided fresh drinking water, supported life, and created microclimates within an otherwise frigid landscape. The surrounding topography, valleys, basins, and ridges could have provided shelter from harsh winds, natural fortification, and routes for transportation and communication. If human populations occupied Antarctica before the ice sheets advanced, these features would have shaped settlement patterns, determining the locations of dwellings, communal spaces, and pathways, much as rivers and valleys structured early civilizations elsewhere in the world. Further evidence comes from the subtle geometric anomalies detected in radar and gravitational surveys. Certain formations appear to have linearity, spacing, and symmetry that would be extremely unlikely to occur by natural processes alone. Channels run straight across otherwise irregular terrain, angles approach right degrees, and isolated blocks appear as though purposefully aligned. The scale of these anomalies sometimes spanning tens of kilometers, suggests planning and design that surpasses what random geological processes would generate. If interpreted as artificial, these features indicate a level of spatial understanding and organizational capability consistent with advanced pre-glacial settlement. Whether these structures serve functional, religious, or administrative purposes is impossible to determine without direct access, but their existence alone challenges assumptions about the historical habitability of the continent. The preservation of artifacts, even on a microscopic level, is conceivable under Antarctic ice. Organic materials, normally among the first to decay, could survive in pockets of oxygen-deprived, cold water, or beneath tightly packed snow layers. Wood, textiles, woven fibers, and even early forms of writing or symbolic material might persist in such sealed environments. Metal artifacts, protected from oxygen and consistent exposure to moisture, could remain largely intact. Stone structures, from foundations to entire walls, would be compressed under pressure, but spatially coherent. In other words, the ice acts as both a shield and a conservatory, maintaining the physical integrity of a past civilization while rendering it invisible to human eyes. The distribution of these preserved features would not be uniform. High elevation regions, which accumulated ice more slowly, might reveal truncated settlement patterns or partial structural remains. Valleys and coastal plains, buried earlier by advancing glaciers, could contain the densest concentration of preserved evidence. This uneven preservation mimics patterns seen in other abandoned civilizations worldwide, where environmental shifts dictate what survives and what is lost. Antarctica's scale, however, amplifies the potential. A continent-wide layer of preservation spanning thousands of kilometers may contain multiple centers of activity, essentially an entire civilization frozen in situ, its history encoded in topography, sediment, and ice layers. Technological limitations have so far restricted exploration, but the patterns detected to date offer tantalizing hints of organized human presence. Satellite imagery, ice-penetrating radar, gravitational mapping, and magnetic field surveys collectively point to anomalies concentrated in the areas most favorable for habitation. These signals may represent building foundations, pathways, terraces, or even larger complexes that remain obscured by ice. Because access is impossible with conventional archaeology, every piece of data requires careful interpretation, as the continent's hidden structures may never be seen in full without future breakthroughs in remote sensing, drilling, or autonomous exploration technology. The possibility of a pre-glacial Antarctic civilization forces reconsideration of the concept of human migration and resilience. If humans or human-like populations once lived on a continent now locked beneath ice, they would have required advanced environmental adaptation, knowledge of resource distribution, and social organization sufficient to sustain life in marginal but hospitable conditions. This challenges traditional assumptions about prehistoric human capabilities, suggesting a sophistication of planning, architecture, and environmental management previously unrecognized for the period immediately prior to the Younger Dryas event. In essence, Antarctica may have supported not simply survival, but structured human activity in ways preserved intact for thousands of years by ice. The echoes beneath the ice serve as both a record and a warning. They demonstrate that environments humans inhabit are fragile, that civilization can flourish and vanish without trace unless preserved, and that knowledge can survive even when the physical world seems to vanish. Antarctica's ice sheet, kilometers thick and continent-wide, is more than a remnant of climatic change. It is a planetary vault containing the faint outlines of a lost human presence. Within it, frozen but enduring, may lie the remnants of streets, buildings, water channels, and the spatial logic of a civilization whose story was abruptly suspended, waiting silently beneath the surface for the moment humanity develops the capacity to read it. Beneath Antarctica's vast ice sheet lie mountain ranges so massive and intricate that they rival any exposed mountain system on Earth, yet they have remained hidden from human view for tens of thousands of years. These subglacial mountains are not merely geological curiosities. They are preserved topographical records of a world that existed before the ice claimed the land. Radar and seismic surveys reveal peaks, ridges, and valleys, whose forms suggest erosion by rivers, lakes, and possibly even human or animal activity. The terrain is complex, featuring flat-topped plateaus, sharply rising peaks, and deep winding valleys that extend for hundreds of kilometers. Such landscapes, sculpted over millions of years, hint at the existence of microclimates capable of supporting life, offering protection from the harsher extremes of wind, cold, and blizzard conditions that define the continent today. If civilization once existed on the surface, these mountains would have provided strategic shelter, natural fortification, and pathways linking disparate regions, essentially functioning as arteries through which life and culture could have moved. The scale and arrangement of these mountains are astonishing. Some peaks rise nearly as high as the European Alps, yet their slopes are unexpectedly smooth, cut not by recent glaciers alone, but by prolonged exposure to erosion from flowing water and sedimentary activity in a climate far warmer than present. Radar profiles of valleys reveal sinuous channels and branching networks resembling river systems, winding between the ridges in ways that suggest long-term hydrological stability. These features would have made the mountains far more habitable than one might assume when viewing Antarctica today. Valleys would have collected meltwater and sediment, forming soil-rich basins, while elevated plateaus could have served as observation points, defensive locations, or even ceremonial sites. The contours of the terrain preserve a memory of a living landscape that predates the ice, a landscape whose natural formations could have guided the placement of human settlements, infrastructure, and transportation routes. Beneath these ice-covered peaks lie isolated basins and depressions that may have contained lakes, marshes, or small rivers. Some subglacial lakes have been identified in radar surveys as early as the 1960 seconds, but ongoing studies reveal that many more exist, often connected by hidden channels flowing under kilometers of ice. These bodies of water, warmed by geothermal heat and insulated by the ice above, remain liquid despite the extreme cold of their surroundings. They provide isolated, stable environments that, in a pre-glacial era, would have been invaluable for sustaining life. The combination of mountains, valleys, and subglacial water systems creates a topographical blueprint of habitats perfectly suited for the establishment of settlements, agricultural practices, and transport networks, revealing the potential for a civilization adapted to Antarctica's ancient conditions. The arrangement of these subglacial mountains often aligns with anomalies detected in radar and gravitational surveys, suggesting a correspondence between natural topography and potential human activity. Rectilinear features, straight channels, and apparent terraces appear concentrated in the vicinity of mountain valleys and plateaus, hinting that any past inhabitants may have chosen to settle where the terrain offered protection, resources, and strategic advantage. This is consistent with settlement patterns observed in early civilizations across the globe, where human activity tends to cluster in areas offering both access to resources and defensibility. The mountains would not have been obstacles but assets, guiding movement, influencing settlement placement, and preserving the spatial logic of a long-vanished culture. Evidence of glacial preservation is equally striking. The weight of overlying ice has compressed landscapes rather than destroying them. Peaks and valleys remain in their original arrangement, and terraces, roads, or any constructed features would retain their spatial integrity. Unlike floodwaters or volcanic deposits that scatter debris, Antarctic ice preserves the geometry of landscapes over millennia. It is conceivable that terraces or artificial platforms carved into mountainsides could survive in recognizable form beneath kilometers of frozen snow and compressed ice, their presence detectable only through careful radar interpretation. In this way, the mountains act as a natural conservatory, safeguarding both the geological and anthropological record. Geological studies suggest that the mountains were shaped by long-term climatic and hydrological processes before the ice advance. Channels within the ranges show evidence of persistent water flow, sediment transport, and erosion patterns inconsistent with sudden glacial activity. Valleys meander, ridgelines converge at angles consistent with river confluences, and erosion features align with the historical flow of surface water. Such terrain would have provided a foundation for human adaptation, creating zones where communities could establish themselves in relative safety and access water, food, and resources without the extreme isolation that dominates the ice-covered continent today. Technological investigation has revealed additional anomalies within the mountains themselves. Radar imaging has detected areas where the bedrock displays unusual symmetry, abrupt edges, and geometric arrangements, not easily explained by natural processes alone. In some cases, linear depressions and rectilinear features suggest roads, terraces, or other forms of planning. While the resolution of current instruments limits definitive interpretation, the correlation between these anomalies and the most habitable parts of the terrain reinforces the possibility that human activity could be preserved beneath the ice. The mountains, then, are not simply natural formations. They may be repositories of civilization, frozen but spatially intact, their form and structure waiting to be revealed. The scale of preservation is unmatched elsewhere on Earth. While archaeological sites in temperate regions are repeatedly disturbed by natural erosion, plant growth, and human reuse, Antarctica offers a rare window into a civilization that could have been frozen at the moment of abandonment, untouched for thousands of years. The mountains, with their complex ridges and valleys, provide the framework for interpreting potential settlement patterns and pathways, offering clues to where structures, roads, and other artifacts might remain. They function as both topographical markers and time capsules, preserving a landscape that could record human presence with unprecedented fidelity. The subglacial mountains also provide a framework for understanding Antarctica's climate prior to the ice advance. Their valleys and basins indicate that liquid water was available at low elevations, and that precipitation and temperature supported the development of soil, vegetation, and ecological diversity. The mountains were not barren peaks isolated in a frozen desert. They were part of a functioning landscape capable of sustaining life. Understanding the relationship between these features and potential human activity allows researchers to reconstruct not only the geography, but also the ecology of pre-glacial Antarctica, offering insights into how a civilization could have existed, adapted, and thrived before catastrophic glaciation sealed the land beneath ice. The subglacial mountains represent a dual reality. They are both a barrier and a record. The ice above conceals their secrets, making direct exploration nearly impossible. Yet the mountains themselves preserve the geography of a lost world. They hold potential clues to settlement, transportation, and resource management, maintaining spatial and structural integrity in a frozen archive. Every ridge, valley, and plateau beneath the ice may serve as a clue to human ingenuity, a record of adaptation and habitation preserved on a continental scale, awaiting the day when technology and persistence allow us to finally read the story encoded in stone and ice. Beneath kilometers of ice, Antarctica may conceal the outlines of something far more remarkable than scattered settlements or isolated habitation zones. It may preserve entire urban landscapes frozen in time, where streets, plazas, and structural grids once guided human activity. The concept of frozen cities is not mere speculation, but a hypothesis grounded in the patterns revealed by subglacial surveys, radar imaging, and gravitational anomalies. Linear alignments, rectilinear features, and repetitive geometries appear in areas previously identified as valleys and plains, regions that would have been conducive to settlement in a pre-glacial climate. These patterns, extending for kilometers in some cases, suggest spatial planning rather than random natural formation. The uniformity and orientation of certain anomalies are striking, aligning with natural topographical features such as river valleys, basins, and mountain plateaus, just as human settlements elsewhere historically emerged in relation to water, elevation, and resource distribution. If these cities existed, their organization would likely reflect the natural landscape, integrating mountains, valleys, and waterways into coherent urban planning. Plateaus may have supported administrative or ceremonial centers, while lower valleys and basins would have contained residential areas, storage zones, and agricultural plots. Subglacial lakes and channels could have functioned as water sources or trade routes, much as rivers did in ancient Mesopotamia or along the Nile. The scale of the landscape suggests a civilization capable of sophisticated environmental management, adjusting settlements to optimize resource access, protection from harsh weather, and transport across challenging terrain. In this scenario, Antarctica was not an inhospitable wasteland, but a continent with urban networks, where human ingenuity molded and adapted to the land rather than being overwhelmed by it. Evidence supporting these frozen urban patterns comes from both radar and gravitational studies. Rectilinear structures, regular spacing, and straight corridors appear concentrated in areas corresponding to preglacial plains and river valleys. Linear depressions align in ways that would facilitate transportation or organized movement, and clusters of anomalies suggest enclosed spaces resembling city blocks or communal compounds. While the resolution of current instruments cannot definitively confirm human construction, the combination of geometric regularity, concentration within habitable zones, and alignment with natural topography points toward intentional planning. These signals, preserved beneath ice for over 12,000 years, may represent a civilization frozen at the moment of abandonment, its architecture encoded in the continent itself. The preservation of these cities would be unparalleled. Ice acts as both shield and conservatory, halting weathering, biological decay, and chemical erosion. Foundations, roads, and terraces remain in situ, compressed by the weight of the overlying ice, but retaining their original geometry. Organic materials, such as wood, textiles, or early forms of writing, could survive in sealed pockets where oxygen and microbial activity are absent. Metal artifacts may corrode slowly, but remain largely intact. In essence, the ice functions as a time capsule on a continental scale, capable of preserving not only individual artifacts, but the very layout of entire urban landscapes. The scale of these potential cities raises questions about population and social organization. If settlements extended across valleys, plateaus, and basins, they could have supported tens of thousands of inhabitants, forming urban networks interconnected by routes that took advantage of natural corridors through mountains and along waterways. Such organization implies governance, resource management, and perhaps even ceremonial or administrative hierarchies capable of sustaining large populations over extended periods. These cities, frozen beneath the ice, would embody not only technological and architectural achievement, but also social complexity, far exceeding what is currently attributed to human societies of the period immediately preceding the Younger Dryas. Subglacial rivers and lakes would have been central to the city's design, providing water, food, and transportation. Settlements likely clustered around reliable sources of fresh water, with channels serving as internal trade routes or communication corridors. Basins that now exist beneath ice could have supported agricultural terraces, gardens, or domesticated animal pens, providing sustenance for dense populations. The presence of geothermal heat in certain regions may have moderated local climates, creating pockets of relative warmth suitable for habitation. Together, mountains, valleys, lakes, and channels would have structured urban growth in a way that integrated natural features with human needs, resulting in a functional and sustainable civilization adapted to its environment. The concept of Antarctic cities challenges assumptions about human adaptability and resilience. Traditional archaeological timelines place complex settlement and urban development in regions with temperate climates, yet the potential for pre-glacial Antarctic cities demonstrates that humans could establish sophisticated, enduring networks even in extreme latitudes before catastrophic climate shifts. The abrupt onset of glaciation would have forced the abandonment of these urban centers, leaving them preserved in isolation, their form and structure intact beneath kilometers of ice. Unlike ruins elsewhere, which are repeatedly disturbed or repurposed, these cities would remain as they were at the moment of their desertion, suspended in time by the ice itself. Technological limitations have prevented direct observation of these frozen cities, but indirect evidence provides compelling hints. Subglacial anomalies align with habitable terrain, linear formations suggest roads or organized infrastructure, and the concentration of features within valleys and plains corresponds to patterns typical of early urban settlement. While no excavation has yet confirmed the presence of human artifacts, the convergence of multiple independent datasets, radar, gravity, magnetic fields points to the possibility of urban-scale structures preserved beneath the ice. In this context, Antarctica becomes not only a site of paleoclimate and geological research, but a potential repository of lost human urban history, a frozen record awaiting discovery. The frozen cities beneath Antarctica's ice illustrate a paradox of preservation. The same forces that make them inaccessible also ensure their survival. Ice conceals but protects. Glaciation erased immediate access, but preserved spatial relationships, structural integrity, and potentially organic material. The continent's extreme environment transforms abandonment into preservation, isolation into conservation, and disappearance into endurance. Every ridge, valley, and anomaly could represent a street, a building, or a plaza frozen in time, waiting for the moment when technology, curiosity, and human determination allow us to uncover the echoes of a civilization lost beneath the southern ice. Deep within Antarctica's ice, the past is not silent, but recorded in microscopic layers of snow, dust, and organic material accumulated over millennia. Ice cores extracted from drilling sites thousands of meters deep provide a continuous timeline of environmental conditions stretching back hundreds of thousands of years, each layer preserving chemical, isotopic, and biological evidence of the climate, atmosphere, and even life itself. Embedded within these cores are traces of pollen from flowering plants, microscopic spores, and algae, all indicating that Antarctica was once far more hospitable than the frozen wasteland it appears today. The presence of these microfossils, often preserved in pristine condition by the ice, provides a direct line of evidence for ecosystems that could have sustained human populations, forming the biological and ecological backbone of a continent that might have been inhabited before glaciation. In addition to pollen and spores, ice cores capture layers of sediment, volcanic ash, and mineral particles transported by wind and water, forming a stratified record of both local and distant activity. These sediments reveal periods of seasonal flooding, river activity, and erosion, reflecting a landscape in which water flowed predictably across valleys and basins. Geochemical analysis of these layers indicates repeated cycles of warmth and precipitation, suggesting that fertile regions capable of supporting plant and animal life existed across the continent. The regularity and depth of these deposits demonstrate long-term stability rather than brief interludes, creating environmental conditions suitable for human occupation and organized settlement. Chemical signatures in the ice provide further insight into past ecosystems and potential human activity. Elevated concentrations of certain elements, such as phosphorus, carbon, and trace metals, correlate with periods of biological productivity, indicating the presence of plants, microorganisms, and possibly animal populations. These markers could also correspond to human or proto-human activity, including waste accumulation, cooking, or early metallurgical processes. Though distinguishing anthropogenic from natural sources requires careful interpretation. The fact that these elements appear in repeated layers suggests long-term interactions with the environment rather than sporadic or accidental deposition, pointing to sustained occupation or environmental management prior to the onset of glaciation. Isotopic analysis of ice cores reveals further details about past climate and hydrology, offering insight into the resources available for potential human settlements. Variations in oxygen isotopes allow scientists to reconstruct temperature fluctuations and seasonal cycles with remarkable precision. These reconstructions indicate that periods of relative warmth and precipitation occurred consistently, supporting liquid water, vegetation growth, and river flow conditions necessary for establishing settlements, agriculture, or managed ecosystems. The isotopic evidence aligns with geomorphological surveys of subglacial valleys and plains, reinforcing the notion that the continent was once hospitable to life and capable of sustaining human populations for extended periods. Microscopic examination of ice core samples has uncovered fragments of organic material, including charred particles, cellulose remnants, and microfibers, suggesting biological processes or human presence long before the ice advanced. Charred particles could indicate controlled fires, a hallmark of early human activity, used for cooking, warmth, or land management. Cellulose remnants from trees and shrubs reveal the types of vegetation that once thrived in the region, providing potential fuel, food, and construction material for human populations. The preservation of these materials in ice offers an extraordinary window into ecological conditions, allowing reconstruction of habitats, resources, and the environmental constraints faced by any civilization that existed there. Sediment layers trapped in ice cores provide a unique record of hydrological and geological activity that could have supported human infrastructure. Evidence of river deposition, floodplains, and sedimentary terraces suggests a landscape shaped by predictable water flows, creating natural routes for transportation, irrigation, and urban development. Valleys would have been fertile, low-energy zones ideal for settlement, while elevated plateaus could have served defensive, administrative, or ceremonial functions. The spatial correspondence between these preserved geological features and anomalies detected by radar and satellite surveys strengthens the possibility that human settlements were strategically integrated with the natural landscape, following the contours of valleys, rivers, and basins now buried beneath ice. Volcanic ash layers within ice cores also provide insight into environmental stability and potential hazards faced by pre-glacial inhabitants. Repeated ash deposits indicate that eruptions occurred but were not catastrophic enough to completely disrupt the ecosystem, suggesting resilience and adaptation among both flora and fauna. For human populations, these events would have required mobility, resource management, and possibly architectural planning to withstand episodic environmental stress. The preservation of these layers within ice allows reconstruction of chronological sequences, revealing patterns of survival, adaptation, and continuity that may have defined early Antarctic civilizations. Ice cores additionally preserve evidence of atmospheric composition that sheds light on pre-glacial ecology and potential human influence. Trapped air bubbles reveal concentrations of greenhouse gases, oxygen, and carbon dioxide over time, reflecting both natural cycles and potentially the activities of early human populations. Variations in these gases correspond with periods of ecological productivity, river flow, and vegetative growth, highlighting intervals during which Antarctica was significantly more habitable. These chemical fingerprints, combined with microfossil and sedimentary evidence, provide a multidimensional record of the continent's environmental capacity to sustain life. The integration of ice core data with subglacial topography creates a coherent narrative of habitability and infrastructure. Valleys rich in sediment correspond with microfossil-rich layers in cores, while plateaus and basins align with geomagnetic anomalies and rectilinear formations detected by radar. This synthesis suggests that past civilizations may have exploited favorable landscapes, managing water, resources, and spatial organization in ways preserved beneath ice. The frozen record transforms Antarctica from a blank, inhospitable continent into a complex environment with zones optimized for habitation, urban planning, and environmental adaptation. Ice cores reveal not only the ecological and geological foundations of human habitation, but also the temporal depth of their preservation. Layers of snow compressed over millennia, trapping sediment, pollen, and gases, effectively suspend history, preserving both the landscape and the biological conditions that sustained it. These frozen archives demonstrate that Antarctica was once a living, dynamic environment, and that human or human-like civilizations could have left traces encoded not only in structures, but in the very chemistry and microstructure of the ice itself. The signals preserved within these cores create an unparalleled record of a continent's transformation, capturing the faint echoes of life, industry, and settlement long before the ice rendered it inaccessible. Beneath Antarctica's frozen surface, radar and satellite surveys have revealed anomalies that hint at a world-long hidden, a landscape that defies expectations of purely natural formation. Subsurface imaging shows rectilinear shapes, linear depressions, and isolated geometric forms that contrast sharply with the surrounding irregular terrain. Some features stretch for kilometers in seemingly deliberate alignments, while clusters of angular formations suggest structured layouts reminiscent of roadways, terraces, or building foundations. These anomalies are not distributed randomly. They occur in valleys, plateaus, and basins that would have been optimal for pre-glacial settlement. Their alignment with habitable terrain implies that, if they are artificial, early inhabitants may have chosen locations that maximized access to water, protection, and resource distribution. These signals create the impression of a hidden civilization encoded into the continent's subglacial topography, preserved under kilometers of ice for over 12,000 years. Some of the most intriguing anomalies are found in elongated depressions that run in parallel lines, occasionally intersecting at precise angles. These features are difficult to explain solely through geological processes, as natural valleys rarely maintain such linearity across long distances. In radar profiles, these depressions maintain uniform depth and width, suggesting intentional design. If interpreted as roadways or transport corridors, they indicate a sophisticated understanding of terrain, topography, and engineering. They connect high-elevation plateaus to lowland basins, potentially linking residential, administrative, and resource zones in a coherent network. The scale and regularity of these alignments suggest that they were integral to the organization of settlements and urban landscapes long buried beneath ice. Clusters of rectangular and trapezoidal formations appear in areas adjacent to these linear depressions. Some resemble the footprints of buildings, terraces, or walled enclosures, with sharp angles that contrast with the rounded forms typical of natural rock formations. These features are often concentrated in patterns that could indicate communal planning, such as neighborhoods, plazas, or ceremonial centers. The repetition of these forms across multiple valleys and plains suggests that whatever activity created them was systematic rather than incidental, consistent with urban organization or structured human habitation. While natural explanations, such as tectonic fractures or glacial pressure, cannot be entirely dismissed, the geometric regularity and spatial relationships strongly indicate intelligent intervention. Gravitational and magnetic surveys complement the radar data, revealing variations in subsurface density and composition that align with these anomalies. Certain areas show consistent deviations from expected bedrock density, indicating the presence of materials with different composition, potentially artificial in origin. Magnetic irregularities correspond with straight edges and angular patterns detected in radar scans, reinforcing the possibility of structures preserved beneath ice. These data layers, when combined, create a multidimensional map of subsurface anomalies, offering indirect evidence of past human activity that survives despite the total concealment imposed by glaciation. The anomalies also correlate with topographical features conducive to pre-glacial settlement. Valleys with detected geometric patterns often coincide with areas rich in sediment and water channels, regions likely to have supported vegetation, wildlife, and freshwater sources. Elevated plateaus near these anomalies could have functioned as administrative, ceremonial, or defensive locations, providing oversight of the surrounding landscape. The placement of anomalies within such optimal ecological zones suggests intentional selection of habitable areas, reinforcing the interpretation that these features may reflect structured human activity rather than random geological coincidence. Ice itself has preserved these subsurface anomalies with remarkable fidelity. Unlike surface landscapes exposed to erosion, wind, and human disturbance, the compression of snow into ice has maintained the relative spatial integrity of depressions, terraces, and potential structures. Vertical pressure may distort some features, flattening peaks or compressing walls, but the overall geometry remains intact. Roads, pathways, and structural layouts would retain alignment and proportion, allowing modern surveys to detect patterns invisible to the naked eye. Ice functions as both concealment and conservation, suspending history while shielding it from destruction. The scale of these anomalies implies an organized approach to settlement and landscape management. Linear depressions suggest transportation or communication routes, while clustered rectilinear features indicate living or working spaces. The integration of anomalies with natural topography, including access to subglacial lakes and river channels, demonstrates a possible understanding of environmental optimization. Such planning implies not only engineering capability, but also social organization, including division of labor, communal governance, and long-term planning, consistent with the development of a complex civilization prior to the onset of glaciation. Repeated anomalies across multiple valleys and regions hint at the existence of urban networks, rather than isolated settlements. These networks would have allowed populations to exploit resources efficiently, maintain communication, and organize defense or ceremonial activity across the continent. The uniformity of geometric patterns, the connectivity suggested by linear corridors, and the correspondence with favorable ecological zones all point to a systemic approach to land use, urban layout, and civil engineering that predates the freezing of the continent. If these structures are artificial, Antarctica may preserve evidence of civilization on a scale rivaling any known ancient culture, perfectly entombed beneath ice. The detection of subsurface anomalies challenges prevailing assumptions about human history. Conventional timelines suggest that Antarctica remained uninhabited until the modern era, yet the combination of geometric features, aligned depressions, and correspondence with habitable terrain implies a past human presence of extraordinary capability and adaptability. The anomalies reveal a continent that was once organized, utilized, and potentially urbanized, offering glimpses of infrastructure, planning, and environmental management preserved in a state unreachable by traditional archaeology. These signals suggest that humanity's history may extend into regions and environments previously thought to have been uninhabitable. The subsurface anomalies beneath Antarctica's ice do more than suggest past settlement. They illustrate the continent's extraordinary capacity for preservation. Ice conceals, but it also maintains the integrity of geometric forms, structural layouts, and spatial organization. Roads, terraces, buildings, and urban networks could lie intact, compressed beneath kilometers of frozen snow and ice, suspended in a state untouched for thousands of years. Antarctica acts simultaneously as a barrier to access and a guardian of history, encoding the echoes of civilization within its frozen substructure, leaving signals that only careful interpretation, advanced technology, and persistent investigation can begin to reveal. Beneath Antarctica's immense ice sheet, hidden waterways reveal a continent that may have once been alive with movement, transport, and the management of resources. Subglacial rivers and lakes, preserved beneath kilometers of ice, form networks of liquid channels that defy the common perception of Antarctica as a lifeless, frozen desert. These bodies of water, some larger than the Great Lakes, are maintained by geothermal heat and insulated by ice above, allowing them to remain liquid despite sub-zero temperatures. Flowing channels connect these lakes, carving intricate pathways through the bedrock and sediment beneath the ice, creating corridors that could have been exploited by pre-glacial inhabitants for travel, trade, or communication. The dynamic yet preserved nature of these waterways suggests that if human populations existed on the continent, they would have relied on them as both a source of sustenance and a means of transportation, integrating natural hydrological features into the layout of settlements and urban networks. Ice-penetrating radar has revealed that some subglacial rivers flow along remarkably linear paths in ways that align with geomorphic anomalies interpreted as roads or terraces. The linearity of these channels is not random. It suggests that past populations may have intentionally directed, modified, or aligned settlements with the natural hydrological grid. Basins and valleys filled with subglacial water correspond to the location of geometric anomalies, hinting at the possibility that rivers and lakes were central to urban planning. Water would have provided potable sources, irrigation for food production, and a means of moving goods and people across the landscape, creating infrastructure that integrates hydrology with social organization, echoing ancient civilizations elsewhere in the world, where rivers dictated the placement of cities, roads, and commerce. Some lakes lie completely isolated, yet their size, shape, and position within valleys indicate that they could have functioned as reservoirs, storing water for human use during seasonal or environmental fluctuations. Subglacial channels feeding into and out of these lakes resemble natural irrigation networks, capable of sustaining vegetation or even small-scale agriculture if conditions allowed prior to glaciation. The preservation of these channels beneath ice ensures that the spatial relationships between water sources, settlement zones, and transportation corridors remain intact, frozen in the configuration they held when human populations might have last traversed the continent. These features suggest an engineered system, one in which water was a critical component of societal planning, managed alongside mountains, plateaus, and plains to create functional networks for habitation and mobility. In addition to natural flow paths, anomalies detected beneath the ice suggest possible modifications to the landscape, such as terraces or levees controlling water movement. Linear depressions adjacent to lakes and valleys may indicate channels deliberately carved to regulate flow or prevent flooding, functioning as infrastructure comparable to aqueducts or canals in early human civilizations. Sediment patterns within these depressions often differ from surrounding bedrock, suggesting movement or deposition that may have been influenced by human activity. If intentional, these interventions imply advanced understanding of hydraulics, engineering, and environmental adaptation, as populations would have had to plan and execute large-scale modifications to support settlements within a dynamic yet frozen landscape. The integration of subglacial waterways with other anomalies reinforces the potential for complex urban networks. Valleys containing lakes, rivers, and sedimentary basins coincide with rectilinear formations detected in radar surveys, suggesting that streets, plazas, and building clusters were intentionally located near water. Linear channels may have served as transportation corridors, connecting residential areas with administrative centers, resource zones, or communal spaces. The spatial alignment between water networks and geometric anomalies implies that early Antarctic populations, if they existed, coordinated their urban planning with hydrology in ways remarkably similar to civilizations in temperate climates, demonstrating an intimate understanding of their environment, resource management, and landscape engineering. Subglacial lakes also serve as natural climate moderators, creating microenvironments where temperature variation is less extreme than at the surface. These stable zones would have been critical for settlement and agriculture, offering areas where food could be cultivated, animals could graze, and human habitation could be maintained with minimal exposure to the harsher extremes of wind, cold, and blizzard conditions. The lake's continued existence beneath ice offers a glimpse into the ancient climatic conditions that would have permitted human occupation and the sustainability of infrastructure, while the stability of water flow beneath the frozen surface preserved the ecological and functional relationships that early populations may have relied upon. The preservation of these water systems is extraordinary. Unlike rivers and lakes in temperate climates, which are subject to erosion, sedimentation, and human modification over centuries, Antarctica's subglacial channels have been insulated from external disruption. Ice compression maintains the alignment, depth, and connectivity of rivers, while subglacial sediment retains the signature of past activity. In essence, these waterways are preserved both as natural formations and as potential conduits for past human infrastructure. They remain a record of hydrological, ecological, and potentially urban engineering that has survived unaltered for millennia beneath the ice. The interplay between water, terrain, and anomalies creates a map of possible urban and transportation networks. Lakes sit at strategic junctions. Channels run along linear corridors connecting anomalous formations, and valleys provide corridors between elevated plateaus and basins. If settlements existed, these features would have dictated their layout, resource distribution, and movement of people and goods. The combination of natural hydrological systems and apparent geometric anomalies hints at an advanced civilization capable of integrating environment, infrastructure, and urban planning on a continental scale, frozen in place yet preserved for discovery. Geochemical analysis of subglacial sediments supports the possibility of human interaction with waterways. Concentrations of phosphorus, carbon, and trace metals preserved in core samples correspond with the location of lakes and channels, suggesting enhanced biological activity or anthropogenic deposition. Microscopic organic particles, including charred matter and plant fragments, appear within sediment layers, potentially indicating controlled fires, food processing, or other forms of environmental modification. Together, the chemical and geological evidence creates a multi-layered picture of subglacial water networks interacting with potential human settlements, where rivers, lakes, and channels functioned as both life-supporting systems and transportation corridors within an integrated infrastructure. The subglacial waterways and infrastructure of Antarctica transform the continent from a frozen wasteland into a landscape structured by water, geology, and potential human ingenuity. The combination of lakes, rivers, terraces, and engineered channels suggests a civilization that understood the interplay between topography and hydrology, exploiting natural features while modifying them to suit its needs. Ice has preserved this record, suspending both natural and potentially artificial elements for over 12,000 years, leaving a continent that holds the faint blueprint of human activity, hidden beneath kilometers of frozen snow, waiting for modern technology to decode its complex network. Beneath Antarctica's thick ice sheets, patterns in the subglacial terrain suggest the remnants of structures and built environments frozen and preserved for millennia, their existence hinted at by radar anomalies, gravitational irregularities, and satellite imagery. Linear depressions, angular terraces, and rectilinear formations recur in clusters across valleys, plateaus, and basins, creating alignments that echo the layout of streets, building complexes, and public spaces in human settlements elsewhere. These formations appear deliberately ordered, with consistent spacing and orientation that contrasts sharply with the surrounding natural terrain, suggesting an intelligent hand in their creation. The ice has compressed these structures, flattening surfaces, but preserving their spatial relationships, making it possible to detect them using modern remote sensing. The implication is extraordinary. A continent long considered uninhabited may preserve the geometric logic of a civilization suspended in time, its architecture encoded in both stone and sediment beneath the frozen surface. Radar imaging reveals terraces and platforms that could have functioned as building foundations or communal spaces. These structures, often rectangular or trapezoidal, vary in scale from small enclosures to areas spanning hundreds of meters, suggesting a hierarchy of use, from individual dwellings to administrative or ceremonial centers. Their placement frequently coincides with favorable terrain, such as elevated plateaus overlooking valleys, or adjacent to subglacial lakes and channels that would have provided water and transportation. The consistency in angles and dimensions suggests advanced understanding of geometry and construction, with designs optimized for both utility and structural stability. These terraces and foundations, compressed but intact beneath ice, may be preserved better than any above-ground structures elsewhere, offering a rare window into the architectural knowledge of a lost civilization. Clusters of geometric anomalies suggest urban organization rather than isolated structures. Rectilinear blocks appear grouped in repeated patterns, sometimes forming grids that echo the layout of streets or public spaces. These grids often align with natural features, such as valley orientation or proximity to water sources, indicating integration of environmental knowledge with architectural planning. If interpreted as communal planning, these clusters reveal a society capable of coordinating construction across extensive areas, balancing functionality with access to resources, shelter, and strategic oversight. The preservation of these grids beneath ice ensures that their spatial logic remains intact, allowing reconstruction of potential urban layouts based on remote sensing data alone. Subglacial terraces and structures show evidence of layering, with some formations suggesting multi-level platforms or stacked constructions. Variations in radar reflection strength indicate differences in material density or composition, hinting at the presence of stone, compacted soil, or other building materials used to create durable surfaces. Some terraces are bordered by linear depressions, potentially serving as roads, drainage channels, or defensive barriers. The combination of raised platforms, adjacent channels, and repeated geometric patterns suggests an integrated approach to architecture, infrastructure, and environmental management, in which human engineering interacted with the pre-glacial landscape to create functional, sustainable spaces. The alignment of these structures with natural topography reinforces the concept of intentional design. Elevated plateaus may have served as administrative centers, observation posts, or ceremonial sites, while lower terraces and valleys accommodated residential areas, workshops, or storage. Access to subglacial lakes and channels provided water and transportation routes, integrating architecture with hydrological and ecological systems. The spatial correspondence between these structures and anomalies, detected elsewhere linear depressions, rectilinear blocks, and consistent angles, suggests a level of planning and coordination unprecedented for prehistoric societies, implying an advanced understanding of site selection, environmental adaptation, and urban design. Geophysical surveys indicate that some terraces may have been constructed using locally sourced materials, such as bedrock, sediment, or compacted soil, which would have been shaped to create stable platforms for buildings, plazas, or other communal spaces. Ice compression preserves these features, protecting both the material and the geometric form. The result is an architectural record frozen in time, maintaining the proportional relationships, orientation, and alignment of structures over millennia. Unlike most archaeological sites exposed to erosion, vegetation, or human interference, these subglacial terraces offer a pristine snapshot of settlement planning, preserved by the extreme conditions that initially caused the continent to become uninhabitable. The integration of terraces, grids, and channels suggests complex societal organization. Linear depressions resembling roads connect clusters of rectangular formations, implying coordinated transport, communication, and spatial distribution of resources. Larger terraces may have served as communal areas for gatherings, markets, or ceremonies, while smaller enclosures accommodated living or workspaces. The repetition of geometric forms across multiple valleys and plateaus indicates that this was not an isolated pattern, but a continent-wide approach to architecture and urban planning, leveraging natural topography and water networks to create sustainable living spaces integrated with the environment. Sedimentary analysis beneath these terraces provides additional context for potential human activity. Layers of compacted soil, mineral deposits, and trace organic material indicate that these terraces were maintained and possibly modified over time. The preservation of sedimentary structures within the ice suggests long-term occupation and adaptation, with terraces designed to withstand both environmental change and the eventual advance of glaciation. These preserved layers allow for a reconstruction of construction techniques, site usage, and the interplay between architecture and natural systems, offering insight into how early populations may have engineered sustainable environments in a challenging climate. The density and repetition of geometric formations imply intentionality, demonstrating that the built environment extended across valleys, plateaus, and subglacial plains. Terraces, platforms, and rectilinear blocks appear systematically arranged in alignment with natural features, hydrological networks, and potential roadways. The consistency of scale, orientation, and spacing suggests standardized construction methods and a shared architectural vision, reflecting an advanced civilization capable of planning, coordinating, and executing complex structures across a frozen landscape. These patterns, preserved beneath ice for over 12,000 years, form a hidden blueprint of habitation, infrastructure, and societal organization encoded in Antarctica's frozen substructure. Ice has maintained these architectural formations in near-perfect condition, freezing both the structures and the relationships between them. Terraces, grids, channels, and platforms remain spatially coherent, compressed but unbroken, and their geometric precision allows modern science to identify and interpret them remotely. These hidden constructions provide a unique glimpse into the possibility of sophisticated human engineering, where environmental adaptation, urban planning, and architectural skill were employed to sustain life in a continent now uninhabitable, but once potentially vibrant with civilization. The hidden architecture beneath Antarctica's ice preserves the faint imprint of urban life, frozen in place and awaiting the development of technology and methodology capable of revealing its full scale and complexity.